really was not liking the way that the book was presenting arithmetic sequences. We hit those again pretty hard in pre-calc. It's all formulaic in there too, but I didn't like the way they were doing it. It was either redundant or antithesis of what we do in later math. So last time we cut it off and said, nah, let's just make sure we got this graphing function stuff down. And then, how many of you caught on? Any of that look familiar? Okay. Some of your test questions were just straight up taken off of here. Okay, I just gave it to you again to see, after so many days or a couple of weeks, do we got it a little better now? Okay. So, those of you who don't have that test done, please get her done. Tomorrow, Spartan time, will be a great time to do that. I will be sending out email blasts to all of the parents, just letting you know the way that freshman classes usually work in terms of parent-teacher conferences is a parent will come in. Maybe they're all riled up because my kid has always been awesome in, middle school, and then we kind of chuckle at them and say, this ain't middle school. And then we tell them all the resources that you have. The open notes, the tutor in the pocket, the review right before the thing, all of the freedoms and responsibilities that you have, and then they turn and look at the kid and glare laser beams through their skull. I don't want that happening to any of you, but just so you know, I will send out an email blast to all the parents, reminding them everything that is available to you in the classes, whether you have or have not used those resources. 99% of their questions can be answered by just reading what I have on the website. And after that, well, that's what you make of the rest of the semester. Okay? This is a drop in the bucket. We're going to have 5 or 6 tests over the course of the semester plus your final. This is one. All right? We can do better than that. So, was there anything, I know we had time to work in class, was there anything that was a little sketchy for us? Yep.
Number 10.
There we go, 10. Is it words or is it fractions? Words. Okay. Oh, that's right. I can 2-page and zoom. Come on, Frank. Okay. You are buying party favors. Party favors are, the little stuff that you got when you went to someone else's birthday party and you got like a kazoo and a stamp and the random little junk. Or maybe you go to a wedding and they've got the little thing of mints in the middle of the table, something like that, a beer koozie, okay? That's South Dakota. Whatever it is, that's a party favor. It's something you give as a favor to your guests. You're going to buy them. They cost $247 each. You can spend no more than $30 on them. What are domain and range reasonable for the situation? If I look at that in terms of a table, say this many party favors, and this is the cost. Say these party favors that I'm going to give everyone is, I don't know, if it was my party, I'd give everyone a fidget. I'd give everyone a little fidget cube or the little gear spinner or something like that. Can I give you 3/8 of a fidget? Can I give you 2/3 of a memorabilia stamp? I can't do partials. So at 1, 2, 3, 4, 5, if I have one party favor, it costs 1 by this. If I have 2 party favors, it's $480.94. 490. Words are hard. 494. If I have 3, if I have 4, if I have 5. When do I run out? Okay, so maybe as an equation, write 247 times something is 30. Or maybe I write it as less than or equal to 30. Because it says no more than. Y'all got a calculator, divide it. 30 divided by 247. Okay, it doesn't come out nice. So when they ask for a reasonable domain and range, reasonable means it has to make sense. I can get to 12 party favors because at 12, I have spent $29.64. But I can't go to the 13th one. So when they ask for a reasonable domain and range, I should have domain, the numbers 1 through 12. Range, I should have all of the 1 through 12 times 247. If I buy 8 party favors, this is how much money I'm spending. And there's never going to be a partial in between there. I'm not magically going to spend exactly $23 because $23 divided by 247 isn't a whole party favor. So I list out my table. That's it. That's my domain and range. 1 through 12 and their corresponding values. Reasonable domain and range. Okay, we talked about that with some of our graphs. Like, I can't have -5 party favors. Doesn't make sense. Technically, I could have 0. Just say, screw you. Coming to my party is gift enough. So 0 through 12, not just 1 through 12. And then their corresponding items. That's it. What else besides 10 and words? Okay. Y'all got a new packet in front of you? Make sure I've got any of the stragglers. Okay, we got a couple kids out. I know that some of you are going to lose your packet of notes. I made sure to print out extra, extra, extra this time. So last time I printed extra and we still had kids looking at the end. Okay, anytime I have something physical to give to you, it goes in the back. Okay. Oh. All right. So we started out like most of the sections. Think. They give you some information. They ask you a question. Puzzle it out with your neighbors. What do you think? Table shows horizontal and vertical distances from the base of a mountain at several poles along the path of a ski lift. Okay, if y'all ever been up to Terry Peak, you know it isn't just a straight line up the mountain, right? It's kind of up and down a little bit. The poles are connected by a cable, between which 2 poles is the path the steepest. How do you know? what? Those were the ones right in front of you. Killing me, Smalls. Okay. Zero talking today. Gotcha. They talk about horizontal and vertical distance. So when I've got poles A and B, I say here's A, here's B. The horizontal distance to pole A, I should say from A to B. This was 20 feet away from the beginning. This is 40 feet away. So if this is at 20 and this is at 40, then I know the horizontal distance between them is 20 feet. The vertical distance. This is at 30, and then it goes up to 35. I know that that distance is 5 feet. They're not all like that. So what do you think? Can you just ballpark it with the numbers there? You got to do some calculator magic? Which one's steeper? What does that mean, steeper? Like, basic vocabulary. What does steeper mean? Goes up faster, right? You ever been in an older house, like one of the ones built 1900s and 1920s, and they've got these itty bitty narrow stairs, and it feels less like you're climbing stairs and more like you're climbing a ladder? Okay? Those are steep versus maybe the stairs coming, going up to the wrestling room. Okay? Those are nice wide stairs. So something that's steep. Well, this went up 5 feet and over 20 feet. What if I kept doing that? What if I said from B to C went over 40 to 60, 20 feet, 35 to 60, went up 25 feet? Well, right there, they both went over, but this one went up 5, that one went up 25. I know that that's steeper, right? They went the same distance this way, but one of them went 5 times higher. Okay, so that's out. BC is my contender. Do it again. You keep trying things. You say from C to D. That went over 40 and then up 10. And this is where hopefully you remember you talked about rate of change in terms of a slope in algebra or in pre-algebra. What do they call it here? Is it pre-algebra or just 8th grade math? Pre-algebra? Okay. Every school calls it something a little bit different. Okay, it's a ratio. We talked about ratios in first semester. Remember, you'd say how many waffles to how many dollars. You would compare two things. You would have x over y equals x over y, and then you'd Jesus fish, right? Cross multiply and divide. Well, these are ratios. 25 over 20. Vertical change to horizontal change reduces down to 5/4. Vertical change to horizontal change reduces down to 1/4. Well, 5/4 is a lot more than 1/4, so I guess that's my steepest one. This idea of slope as rate of change. I don't know how many flashing neon lights and exclamation points I could put on that. Slope is rate of change. And the vast majority of the Algebra 1 level questions that you will see on an ACT, an SAT, an AccuPlacer to get into a tech school, the vast majority of those questions are going to be based on this concept. Rate of change. We've already talked about rates in here. Okay? A good number of you already have a job or have had a job, maybe a summer job. Your rate, this many dollars per hour. If I work this many hours, I will get this many dollars because that is my rate. A rate of change is something we use in math an awful lot, and it's kind of the basis for the rest of the semester. Okay? This is a big, big, big deal. A rate of change. Okay? We have table shows distance, band marches over time. How many of you are in the do the band? Like, I see them every fall out on the practice field. Like early morning, 7 a.m. practice. Any of you in that crew? No? Yay for you. I feel sorry for those kids. Because I'll drive up to the school and I hear, is it Apple? Yeah. Hear Miss Apple out there with the megaphone yelling at kids. Like, you have to be in a certain step and a march, and they're all, right? If I got a table that tells me two different things, they're going to be input and output. Next to this rate of change, I would like you to also have on there rate of change is going to be not just change in distance and time. That's this problem. I want you to have change in output over change in input. Maybe next to those, we also say change in the dependent variable over the independent variable. I can't I can't scream that one loud enough. I used to write test questions for MCA when I taught in Minnesota. I was one of the guys who wrote some of the questions for the Smarter Balance test. Y'all remember doing Smarter Balance throughout middle school? Okay, I did some of the high school ones. Rate of change is simply that important. I would rather you had that yellow, green, pink one than what they have. That's specific to this problem. When I say change in output and input, you remember what we said about time as it's involved with these problems? 99% of instances, time is going to be my input, my independent variable. That's why it's on the bottom. Think about something per time. Think about how many things in our world, in your daily life, is something per time. Your job. How many dollars per hour do you earn? Right? Not bad for a freshman. Where do you work? All right. Not, dang, not bad. Okay. How many miles per gallon your vehicle gets? Well, the amount of distance I can go depends on how much gas I have. So gallons is my input. And then it'll tell me how much I drive. If I say how many, well, go back to the car, how fast are you driving? Miles per hour. Whenever time is involved, 99% of instances, it's your input. So when they ask, what is this as a rate of change? You pick any two of these numbers, might have to do it a couple of times, and you compare them. Okay. If I go from here to here, my input changed 1. How much did my output change? 260? Okay. If I go from here to here, again, my input changed 1. Was it 260 again? Okay. They might be the same. I don't know. Maybe they end up all being the same. Maybe there's one that's outlier. I try one more time. My input changed by 1. My output, 260 again. So my rate of change is 260 over 1, which is just 260. But then I have to make sure to put the proper label on it. I'm going to say 260, and then whatever your label is, it's your output per input is how you say them. So in this case, it's going to be 260 what per what? Feet per minute. And that should start looking more familiar because physical science. Okay. Those unit conversions that we did first semester in both AlgHalf and physical science, unit conversions, it's a bunch of fractions and ratios. Ratios are rates. If I go from this frequency of light wave to that frequency of light wave, there was a change, so I'm able to find a rate of change. Okay? You've dealt with formulas about acceleration. My rate of acceleration might not be as steep if I'm just nicely speeding up because I'm getting outside of town versus I'm stomping it to get around Granny who's going about 3 miles an hour downtown. Right? You all know the old, like, how are you going this slow without actively being on the brakes? You know those people. So, so down here, do you get the same rate of change if you use non-consecutive rows? What does non-consecutive even mean? Okay, take the non out of there. We know that means not. No. What is consecutive? Hmm? Constant. Like one after another, right? When you hear 5-time consecutive world champion, means one after another, right? So if I use non-consecutive, that means points that aren't one right after another. Choose something different. Choose like from here all the way to here. Input time. How much did it change? From 1 to 4. Oh, from 1 to 4. 3. Remember?
780.
780. Y'all got a calculator? Divide it out. Reduce it. Do 780 over 3 and hit enter as a fraction. And it comes out as the same. Still 260 feet per minute. Okay, and it's because they reduce down to the same thing. That means that this is keeping a consistent rate of change. That's what makes it a line instead of nonlinear, which was the stuff we did last time. Okay. That slope, right smack in the middle here, slope is vertical change and horizontal change, which you're probably going to hear most often as rise over run. Please tell me they told you this in middle school. Okay, rise and run. What I want you to put next to it, again, this is 14, 15 years as math and special education teacher, working specifically with interventions for kids who struggle with this. Over here next to Rise and Run, I would like you to please, oh please, oh please, next to Rise, put this and run this. Okay. It is that big of a deal. Those little arrows hopefully are going to keep us from screwing up the direction. I got an algebra class that's specifically meant for kids who really struggled in half. Like it's an instructor permission class where we slow things down. It's less of an algebra 1, more like an algebra 0.7, where we take our time and make sure that we understand these concepts and sprinkle in a little bit of what's absolutely necessary to move on to geometry. And this right here, I'll tell you, I got kids who have never seen anything higher than a D on anything they've done in math in their life. I show them this, and they're rocking A's on their tests because they put this next to every problem, or they put it at the top of every paper. We beat this to death because I asked them, how many times do you make the line and it turns out you went in the wrong direction? Like, your ratio of steps is right, but your steps are going the wrong direction. This will hopefully keep us in the right way. If something is positive or negative, that tells me if I'm headed up or down. The run will be always left to right like a book. Okay? Now for our manga readers in here, you're just going to have to ignore that. Okay? Left to right like a book. If I'm always going left to right, now we're going to switch it up where I can do the opposite if I need to. But if you're always going left to right, then the plus or minus tells me, is it going up or down? And it's very intuitive that way. Positive is up, negative is down, as I go left to right. And then it's just a matter of counting boxes. These get real easy. What is the slope of the line? Well, y'all probably remember making these little triangles here. Between any 2 points, I went up and to the right. Don't count backwards. Like doing this. Bad. Okay, now we can do that later. It's a little bit more advanced, but right now, as I go left to right, you know what? Maybe I do that instead of going up and then right. Maybe I go right and then up. In both cases, you see my arrows are going left to right. Left to right, left to right, left to right, left to right. I can't stress that enough. Think about when we did PEMDAS. Remember, there was that little trick that says multiplication and division happened left to right like a book. Addition, subtraction happened left to right like a book. If you always do your slope left to right, then I see that this is going up 2 and right 3. Since it's up, I know it's a positive. So my slope is just 2/3. That's it. Something else to write next to this is we will always reduce that. What if that was 12/3? Okay, we would go even further and call it 4. Just 4. I got to know that when I make my points that it's over 1, but I would write it as just plain 4. Okay, you just count in boxes. Again, you see their arrow is going to the right. I think this book is the one that had a penchant for always doing up or down first and then left or right. If I go down 4, right 5 versus right 5, down 4, in both cases, to the right. Don't back up. Don't go that way. Okay. Any of your parents ever tried to maybe rent an RV or a trailer and you know that mom or dad never really drives something that big? They're not pulling up to a gas pump and then backing up because they missed. They have to go all the way around the block and try it again. Okay, there's no backing up here. We are always going to the right. And I say, what did it do to the right? Well, 5 units. If I'm going to the right, I see it went down 4. So I know it's negative instead of positive. Now that might seem like a simple concept where I'm just banging that drum and you're saying, yeah, I get it. Why are you, stop it. Because I see this year after year. I have kids coming up into Algebra 2 that forget this and they screw this up. I've got kids who are seniors who will forget this little direction trick all the way on their ACT, and then they do a big old forehead slap because it ended up costing them a couple of problems just because they missed that negative trick. Okay? It is that important. If you can get that through your head, have that absolutely blasted in, then these are just count boxes. So, count boxes. Just make sure you got your sign right. Okay, draw your little arrows. Go to the right, from one to the other, to the right, then up or down. Okay, draw your little triangle, go to the right, then up or down, and that'll determine your sign. Okay. Oh, also, I know I do everything up here multicolored. It's nice and easy to figure out what's doing what. Doing it on black and white paper where there's just letters, numbers, and lines everywhere might be a little visually overwhelming, or it starts to mix together in noodle soup. If y'all ever need colored pencils, highlighters, anything like that, I got boxes full of them up here. You can just borrow them in class. Okay? Like a kid the other day asked about colored pencils. Was that in here? Yeah. Do you have a colored pencil I can borrow? And grab that and just in front of her. Yeah. Borrow them. Use them. If it helps what you're doing. Okay? I've done this with different colored papers. Anyone ever tried that as an accommodation? Switching your printed materials over to a different colored paper? It can actually like help some kids. Something about the contrasting colors, it just works. Okay, if I go left to right, always do that first, from one point to the next. Then I see that I'm going up 2, so it's positive 2. Right, 1, 2, 3, 4, 5. If I go left to right, and then up or down, I see it's down 2 this time, over 1, 2, 3, 4, 5, 6. Are both of these done? What is it? Okay. Okay. Even if it helps you to actually put the arrows next to them like this. I got kids doing that in my algebra class. We've been graphing lines for a couple months, and I still see some of them putting those on every single thing that they graph because it just helps. Okay. So, did you run across the slope formula in middle school? Hmm,
Maybe.
maybe. Okay. It can look a little goofy because they use something that looks like exponents, but it ain't exponents. It's a subscript. A subscript means this one. It doesn't mean squared, doesn't mean times 2. It's telling you which one. Kind of like you've all seen H2O, right? It means 2 of the H's. It has a different meaning in chemistry. In math, it means the second Y. That's all this means. In fact, that might not be a bad idea to put on there. It's the second Y minus the first Y. It's the second X minus the first X. That's all it means. Okay? It doesn't mean times 2, times 1, doesn't mean squared. It just means the first and second one. That's it. See, if I want to know how much something has changed, I usually subtract. Okay? How many of you in the last year have sprouted? Okay? Like this time last year in 8th grade, you were a solid 8 inches shorter than you are now. Okay? You always get a couple of those. I got one of the kids in my game club right now as a junior. Kid's about as tall as me or a little bit more, beanpole. 2 years ago as a freshman, he was Killian size. He was this itty bitty little dude and he squeaked when he talked. And now he's this big man child. Okay? If I want to know how much he grew, I take his height now and subtract his height then. That's the change. If I want to know what time it was, well, I'll take junior, 11, minus freshman, 9. It's been 2 years. So I find change by subtracting. This is a formal way to count out the boxes on your graph. If I want to know between any two coordinates, how far did it move? Well, to go from colors, to go from this y to this y, well, it went up. Instead of just counting the boxes, I can subtract. I can say 5'11" minus 5'8", right? Up 3 inches. There was 3 inches of change. If I want to know how far my x has changed, well, I go from this x to that x. From freshman year to senior year, I'll take 12 minus 9. It's been 3 years. Okay? So, or in this case, it went over 4, but you get the idea. It's a formal way to write out how do I get these points? How do I get that slope, that rate? So, right here, they're going to ask, what is the slope of each line? These, oh, did I miss it? Got it too. Oh, I put the same thing. That's right. Remember what I'm doing now. So we just did this one. We know that the slope was up to and over 5. What I want to show you is that it still works in terms of coordinates. I'll write each of these. What is this point? This guy?
Oh.
back 3, just the point itself, the coordinate. Negative 3, 1. What is this point? Okay. So my formula says the slope, they use a cursive M, fancy M, for slope. And I'm guessing they use M just because S looks like 5. They wanted something a little bit different. So if the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right next to this, big honking neon letters, parentheses. Please use parentheses. Next to this, I've got thing minus thing is thing minus thing. Set up the parentheses first. If you do not use parentheses, I guarantee you're screwing up a negative somewhere. At some point, you will goof a negative. So, how do I know which one's the first x and the second x? Yeah, left to right. Okay, so call this x sub 1, y sub 1. X sub 2, y sub 2. So if I have this, y sub 2 and y sub 1 are going here. Don't write those. I'm going to write over them. X sub 2 and x sub 1 are going here. The reason I like those parentheses is because you can just mix and match now. You can replace y sub 2 is 3. Y sub 1 is 1. X sub 2 is 2. X sub 1 is negative 3. You see how you might screw up that negative on the bottom? How it's a double negative? What'll happen is kids will see that minus in between the x2 and x1, the y2 and the y1. They'll see that negative in the formula, and then they'll get a negative number and accidentally just write 2 minus 3 because they're not using parentheses. They're like, oh yeah, they just put the negative there for me. Y'all, math ain't nice. Math isn't courteous like that. They're not just going to put something there for you. That's why we use our parentheses. Okay, 3 minus 1, 2. Add the opposite. 2 plus 3 is 5. Okay. We're going through this nice and slow at the beginning. After a while, this is going to become second nature, like mental math zoom mode. Okay, so I confirmed, hey, yeah, that's 2/5. That's what I had before. If I take this same thing over to the other one that we did, we said this was negative 1/3. If I plug in my points, this is at negative 3, 2. This is at 3, 0. Plug in the points. Might not be a bad idea to write what they are first. First x, first y. Second x, second y. Plug and chug. Okay? I'm going to get used to that one throughout high school too. Plug and chug. We love that because it means I plug numbers in a formula and just chug through the order of operations. Second y, 0. First y, 2. Second x, 3. First x, negative 3. Again, there's that double negative. I have to be careful for it. Then, 0 minus 2 is a negative 2. Minus a negative 3, add the opposite. And then reduce it down wherever you can. We throw our negative out front. Remember, the negative can go to the numerator, the middle, or the denominator, not all of the above. Putting a negative on denominator is considered kind of taboo. It's like wearing the underwear on the outside. Okay? Superman was lying to you for decades. He was lying to your grandpa. You ain't supposed to do it. It looks funny. Okay? I'm not supposed to have a negative on denominator because it looks funny. So, when they say, what is the slope of the line through these two things? I don't have to graph it. Now, I'll graph it afterwards. I put this here just to show you. But I label first x, second x. Yeah, first x, first y. Words are hard. Second x, second y. As we're first doing this, I would strongly recommend that you get used to labeling them like that. These aren't things I'm telling you to do just because they're redundant and dumb and I want you to do a dumb thing. Experience, okay? These are little tips and tricks that help keep things straight. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I will say parenthesis minus parenthesis. Butt cheek minus butt cheek. Okay? Set it up with parentheses first, then plug in the numbers. Second y, second y, second y. Okay? First y, first y, first y. Plug and chug. It's like sorting Legos. This thing goes here, that thing goes there. Second x, second x, second x. First x, first x, first x. And they did that double negative to us again. That's why I got parentheses there. So I remember minus a negative is actually add the opposite. Negative 2 minus 0 is still a negative 2. 3 plus 1 is a 4. Simplify it down. And just to show you that's what it is, those points, negative 1, 0, and 3, negative 2, if that's my line, and 1.5, no, down 1 or 1.5, there we go. I can't draw a straight line to save my life. Use a straight edge. I see to the right 4, down 2. Right 4, down 2. Same thing. What this allows me to do is find the slope without having to graph it. If you want to graph it, go for it. But you do not have to, because now you got a formula where you just plug numbers in. Okay, that formula is just a formal way of saying subtract them to find out how far apart they are. Okay. You're 14. Your older sister is 23. How many years between you? I would subtract, right? 23 minus 14. This is just a formal way of doing it. So, get yourself a formula, plug numbers in, get them. Plug and chug. Word caution on these. It might be very tempting to start going mental math mode on them. At least write out the parenthesis thing and then go mental math mode. Or even dump it in a calculator for all I care, if you can't fraction. But at least have this written out. Because if you write the incorrect answer with nothing to back it up, I would really hate to take off 5 out of 5 because all I see is a number and nothing to back it up. But if I see you've got all the right numbers, you just accidentally swapped your X's and Y's. Now that's a 4 out of 5 instead of a 0 out of 5. Okay, if you've only got a handful of questions on a test, every one of those little points matters. I don't want to give you a test with 6 of the same type of problem. Okay? Every time you do these, they should come out as either a single whole number, or I should say an integer, over an integer. Well, right now, we'll get uglier ones later. And then the final answer written as a fraction. First x, first y. Second x, second y. Plug them in. Second y, first y. Second x, first x. You owe me $1, you borrow 3 more. You owe me $4. I have $4, I spend 1. I can't simplify it, I'm done. Don't try writing it as a coordinate. Don't say -4 comma 3 or 3 comma -4. It's a ratio. This ratio is telling me that for every 3 steps to the right I take, I'll take 4 down. Okay? It is telling me if I'm at the point 4, -1, and the point 1, 3, in between there, I went down 4, right 3. It's a ratio. Okay? Horizontal and vertical lines. Well, if I say rise over run, from here to here, how far does it rise? 0. How far does it run? What's 0 divided by 5? 0. For example, I see, well, there's 6 of you right here. Not Dominic. There's 5 of you right here. I have in my hands 0 brownies, and I'm going to share it with all 5 of you. Y'all get nothing, right? Because I've got nothing to split up. Versus the opposite of that, if I try to look at the rise and run for this, rise, is it 3 or -3? I can't really figure that out because it has no run, right? So whether I say this or this, either one of those, what's a number divided by 0? Get a calculator. What's 3 divided by 0? Get a calculator. Try it. Nothing. Not even 0. Divide by 0 error. Undefined. Specifically, that's what we call this. undefined. Meaning I can't even do it. It's not even a concept. Okay? This pen is about 5 inches long. Okay? Yes, ma'am? Roger that. Thank you. Aiden, you were gone at 3. We got 10 minutes, but at 3, bye-bye. Okay. If this is about 5 inches long, if I said, what's 5 divided by 0? I dare you to cut this into 0 pieces. You can cut it into 2. You can cut it into 2,000. You could run it against a sander and put it into 2 million. Can you cut this into 0 pieces? You get that one smart aleck kid who's like, look, I did it. That wasn't division. I didn't cut it into pieces. I subtracted it. I took it away. I can't divide something into 0 pieces. It's not possible. So this is called undefined. Even if you just call undef. Okay? But I don't want you to say is 0. You might see some people write the no solution, the empty set symbol for this, because the set of values that it equals is empty. You might see other books or teachers call it no slope. What is the slope? There isn't one, because it's undefined. I can't even put a number. So, the slope of a line between given points. Well, again, if I were to write this out, slope is thing minus thing over thing minus thing. Slope is thing minus thing over thing minus thing. If I were to plug those coordinates in there, y2 minus y1, x2 minus x1, that's where that 0 over 5 comes from. y2 minus y1, x2 minus x1. I get negative 3 over 0. That's where these are coming from. So go ahead and dump these into your little formula and tell me, what's the slope? They're probably going to be 0 or undefined. And then maybe we see a pattern, a trick to do it faster. But write it out with parenthesis minus parenthesis, parenthesis minus parenthesis. Okay, start there. This is going to sound a little random and it's completely personal and has nothing to do with this. Were any of you 15 before this year started? Before your freshman year started, you were 15 this summer, came into your freshman year at 15. Okay. That's where we're at. Is my oldest is June 25th. So, like, do we put him in kindergarten next year or not? I really don't want to. I'd rather that he was just the oldest one in the class than the youngest. But just wondering ratio wise. Um, I'm going to have slope is thing minus thing over thing minus thing. Slope is y2 minus y1 over x2 minus x1. I plug in there. x1, y1, x2, y2, x1, y1, x2, y2. Plug them in and get 2 minus a negative 3, 5. 4 minus 4, 0. Is that 0 or undefined? Undefined. Okay. I have a negative 3 minus a negative 3 is 0. I've got a 5 minus a negative 1 is 6, and I call that 0. Okay. I want you to look at all four of those. Do you see a little trick? If the coordinates have "neh," I know it's going to be undefined. I want you to write that. I want you to write that. Or if the x's are the same, well, the x's were the same here and the x's were the same there, and they both said undefined. So if my y's are the same, my y's were the same, my y's were the same. Both of them ended up as 0. Okay, handy little shortcut if you recognize it. Now they can't crossfire. You can't have like a negative 3, 2, and then a 2, negative 3. I can't say, well, that's the same as that. Doesn't matter. That's an x, that's a y. Okay? Nothing to do with each other. In fact, that's a big gotcha problem that books like putting in as problem sets. Okay? Next to each of these, if I'm always going left to right, you notice the directions on them. From left to right, from left to right. It tells me whether I'm going to have a positive slope, a negative slope. The way that I always remembered it was I'm going up the hill, I'm going down the hill, negative. I'm going cross country, and I'm falling off a cliff, so my remains are undefined. You fall off the cliff, splat. Your remains are undefined. Okay. Now, if you've seen parts of this in 8th grade, I gotta ask. Depends on the teacher. Some teachers love this. I know Mrs. Work and Mrs. McCreary, I think, like this. There was something called Mr. Slope Guy. Those are the 4 different kinds of slopes. Greenwald did this? Okay. The 4 different slopes, right? You have up the hill, down the hill, undefined, and 0. And just makes a big, like, golem looking dude. Mr. Slope Guy. Some people love it, some people could care less. But I remember watching a certain teacher printing out and laminating like 4,000 of these things before and handing them out to kids and saying, don't you dare lose this in your high school career. Mr. Slope Guy. Because it works. right? Positive, negative, undefined, 0. It not only tells you what they are, but it gives you an example of each right there. Okay, so those are your 4 types of slope. I would like us to do, I think we're fine with, like the counting boxes thing, we're probably fine with. But what about plug and chug on the formula? I'd like you to do the bottom 4. 6, 16, 7, and 17. I'd like you to find those 4 slopes, compare it with your neighbors, make sure that you have the same sign, not just the same numbers, but the same sign. Use your little formula cheater. Good journeys, young sir. Don't get stuck in a snowbank. Choices be made. Okay. Yeah.
What happens when you get 0, 0? Is it just nothing? Or did I do something wrong?
We did do something wrong, but that is something I want to talk about. It's a good question, but we did goof up a sign in there. Okay, remember, even if you can do the mental math mojo, write this. What happens when you do your daily quiz on Friday and you think, well, I just know it? And all you wrote was 2/11ths, and it wasn't right. Now you just got a 0 out of 5 because you got nothing to back it up. Okay? Write this out. Do it for real. Yes, ma'am.
Am I on the right track?
You're certainly setting them up well. It's just a matter of if we're putting the right thing in the right spot.
Oh.
4, 4, 7, 5, 8, 6. Cool. 5, 5, negative 2, 2. Okay. 3, 12, negative 5, 6.
Yeah, that needed to be flipped around. That needs
Actually, I want to talk about that one. Okay. Like, I want to talk about that one. Yes, ma'am.
Oh, I'm just wondering if I'm doing that right. Like, for my phone, like, that one expression.
Yes. They all look solid. Pretty sure. Yeah, I think so. Okay. I would absolutely start by labeling x1, y1, x2, y2. y1, x1, x2, y2, x1, y1, x2, y2, x1, y1, x2, y2. I would absolutely label them. And then go plugging stuff in. Put 8, 6, 4, 4. 2 over 0, last I checked. Can't do that. Negative 2, 2. 5, 5. Get negative 4, nothing. Okay, don't use that symbol. Put 0. Again, undefined. Over here, negative 5, 6, 3, 12. Getting a negative 11, and then a negative 9. (11 over 9). It was negative 11 over negative 9, and then it becomes 11 over 9. Now, the question was asked, no, bad Frank. If I say x1, y1, x2, y2, and I plug in negative 2, negative 9, 3, 5. Is that going to give me the same result? What if I did the other way? What if I accidentally swap those? What if I had it backwards? I'm going to have now a negative 9 minus a negative 2 and a 5 minus a 3. Here I get a positive 7 over a negative 2. But here I get a negative 7 over a positive 2. Are they the same? Yeah?
Wouldn't they be the same since the negatives just mean like the entire fraction is a negative and it doesn't matter if you put it on the top or not?
What's a negative 1 divided by a negative 1? 1. What's anything times 1? Itself, right? So I could take this times negative 1 times negative 1, get negative 7 over positive 2. Take this times negative 1, 1 times negative 1, getting 7 over negative 2. I just showed that they're the exact same thing. Because, like you said, I can take that negative out front. Both of them are a negative 7/2. So no, it does not matter which way you do it. What you got to be careful about, though, is this is y sub 2 minus y sub 1. This is x sub 2 minus x sub 1. They're both firing in the same direction, right? Any of you ever done any shooting? Go to a range? If they're all firing in the same direction, you're good. But what happens if I try to say negative 2 minus negative 9 over 5 minus 3? I just said negative 2 minus negative 9, 5 minus 3. What's going to happen at the range when you're both shooting this way? Someone's getting hurt. Okay? So you can call whichever one 2 or 1. They just got to be going in the same direction. Okay? You have to be consistent. I can't call this x sub 2, y sub 1. They both are 2s or both are 1s. Another good question was asked. Now, you saw the error with the sign, right? Found it? What if I have something like 5, 3, 5, 3? What's the slope? Wait, because the x's are the same and the y's are the same. So I'd have 0 over 0. There's no slope because it's just a dot. It is still undefined because there's not even a line. It's literally just you are here, and that's it. Okay? That's it. End of 5-1. I'll put the assignment up right now. Remember, when you come in on Friday, you need to have your chapter 4 and 5 packets. You should have, I think, after Friday, there will be 3 daily quizzes and 4 assignments. Okay? Because remember, the first day of 4-7, we didn't do one. And then after that, I just didn't like our 4-7. So, you got all that stuff. Have it ready to turn in. There were a couple of you that were missing some things from week 1. I still take it. Okay? I'll take stuff from kids from week 1 all the way in week 18. All right? I will always give you credit for going back and doing the thing. So just, if you missed anything from week 1, get it done, turn it in this time. Okay?